everyone. I'm Christian.
I'm Jesse.
Wallace.
I'm Jeff.
And we work with our sponsors, Anil and Ron from Xactly on distributed performance monitoring. So some background on Xactly is they are working in sales performance management, which means that they perform incentive-based calculations for sales-based businesses. They'll calculate things like percentages of quotas, bonuses, commissions off of the amount of sales that a person in the sales company makes. There are multi-tenant software as a service, so each of their users shares resources on their system. They are service-based software, so their users pay periodically to use their service. They calculate hundreds of millions to even billions of highly structuralized, normalized data across various environments like every week. And they have a continually expanding distributed computing platform that they use to calculate this extremely large amount of data. So this is kind of gives a good example of how Xactly works. There are all these so all these companies on the left have different storage methods that Xactly needs to use this process called ETL, which stands for extract, transform, load, to extract the data from these different storage areas, transform it into a form that they can do their incentive calculations on, and then load it onto their servers where they perform the incentive-based calculations, and then they output resulting payments to different payroll companies. So our problem statement is as these distributed servers grow in size, it becomes a challenge to maintain them. As you can see from this graph of the data flow, it can be extremely complicated to figure out what's going on, as there's hundreds of different servers all working together. So we needed a centralized platform to be able to collect metrics from these servers, troubleshoot the problems easily, so you don't have to go crawling through a log file to find out what's going wrong, plan capacity so you can see how much load is on the servers at a given time, so you can scale your servers to meet the customer's demands, and identify patterns in customer habits, so you can kind of see when customers want most of their payroll data to be done. So our project goals were to create a platform for metrics, collection and reporting, collect server and application metrics, and then visualize real-time and historical metric data to get a good overview of the infrastructure and identification of problems in real time.
So how we approached the project was to figure out and research on how we would collect the data, store it, and visualize it. So for collecting data, we want to collect various metrics from various infrastructure components like their CPU, load, memory, disk I/O, and network. We also wanted to modify the tools we'll be using to also collect application metrics like Xactly incentive calculations and their analytic ETLs metrics. After that, we want to store all these metrics in a fast, reliable database which can scale out easily. And also, we want to visualize all these metrics in a nice graph where the user can easily understand it, and also implement a Gantt chart feature where you can see for a particular metric across multiple servers on one single graph. So the tools we use for this platform is OpenTSV, which is an open source time series database, which is fast and reliable, which also use HBase as its backend, so it's easily able to scale out. Also, we use T-Collector, which is written also by the OpenTSV community to collect metrics from the systems. Then we chose Grafana, which is another popular open source tool that can plot these metrics in nice graphs. So basically, how it works is that there are metrics all over the infrastructure, ranging from servers to database. So using T-Collector, we can just collect all these metrics and then pipe it into OpenTSV and store it. Then using Grafana, we can retrieve all these metrics back and plot them out.
So we collected 3 metrics. The first one is incentive calculations, and they're called jobs here in the slides. Here we have the job count and the total number of jobs that have been ran. And then there's the job durations, which are shown in a Gantt chart, which will be explained in the next slide. And we have input output volume, data volume, which comes in the form of payment counts, commission counts, credit counts, and item counts. So these are 2 graphs of job task durations for one specific business using the same data points over the span of a day. And for the line graph, you can tell the line is a task, and the high points represent the durations, and with the diagonal, you can see that a single task will have multiple instances with varying duration. But if you wanted to find out where these jobs are concurrently running or running really close together, it's really hard to find out like these clumps. But it's really easy with the Gantt chart that we made to find the hotspots. And this goes back to what Chris was saying earlier about identifying customer patterns for data processing. So you can find all these diagonal lines will get in the way, and you can see all these dead spots that you can optimize with. Worth mentioning that the y-axis represents or shows us a list of servers. So these are all the servers. If you go row by row down the y-axis, you can see the sequence of tasks that they run over the span of the day. Then we have the ETL metrics, which we explained before, which is extract, transform, and load, number of runs, durations, and the number of steps that succeeded or failed. There are 180 in total, and this is a subset, another Gantt chart of them. This one shows us a Gantt chart in the true sense, I guess, with the bars representing the duration of each step, and this one is sorted by start time, so you can see and compare how each step comes in sequence.
So going back to the server metrics, here right now we have some of the basics in. Xactly has other tools for monitoring these, but by having them available as dashboards, they can be easily correlated with other metrics that we're tracking. Here we have memory usage, CPU usage and CPU load, disk space used and free, and network stats easily available to view. And then with the Gantt charts, if you mouse over a particular time bar, you can see job type, what type of calculation is being run, task name, which is automatically generated for the specific job, runtime, so just how long it took, and business ID, which will go with a particular client of Xactly's that's running the job. You also have filtering on the Gantt charts. Say you have this up here, you want to filter out all of the little bits of chaff that are just really quick jobs and focus on what's taken a long time to run. So these few, you can go in and say, all right, I want to filter it by 4 minutes. Oh, 4 minutes. And so then you'll go from all this to just having these pretty easily viewable solid chunks where you can see, okay, what's taking a bit longer than you want it to. And so our results are we successfully collected together all of our metrics from various sources, CPU, server statistics, different jobs being run, collected those all together into one place, took those and loaded them up into real-time and historical visualizations in Grafana, so you can easily go and see, say, what's going on right now, just kind of get a bird's eye view of everything going on without having to dive into log files, or then also if you want to go back and see, like, all right, how were things running yesterday, try to figure out maybe if there are some problems with that, why that was happening. And so putting that all together makes it easy to identify service delivery problems that are going on, since you have these easily accessible heuristics for how everything is running. And so going forward, extending and solidifying our metrics collection, basically add in more additional metrics so we can have more dashboards, more things that can be easily monitored with our system, and also making sure that everything we already have in there is working really solidly and is showing what we're expecting it to show. And then also getting into automating problem assessment using some machine learning, figuring out how to make metrics that'll be predicting when things are going to stop working the way that we want them to, as opposed to waiting until problems already are surfacing. And then we'd like to give thanks to Professor Julig, Grace, and our sponsors for making this project possible. Any questions?